Hello, everyone. It's a pleasure to be here. Just as a quick heads up, this lecture and I think also the next one after it are going to be in English. Hope that's not a problem for you. So let's begin. As he said, my name is Ivайло Караманолев. I'm a tech lead at HyperScience. Some of you may have some illusions about what a tech lead is. I'm here to tell you that this is the person that no one listens to and then everyone blames when things don't work. So I'm the one who makes things don't work. A few words about HyperScience. That's the pretty awesome company I work at. We basically do artificial intelligence for the enterprise. We have a few big clients in the US, and we have offices in Sofia, New York. A few quick facts you can see on the slide, but you can always learn more information on our booth outside. Everyone is welcome, and we're also hosting an interesting game on AI everyone can participate in. So let's begin. What do we mean by easy long-term maintenance? A lot of you know how you feel and that awesome feeling you have when you start a new project. You are discovering all the new cool technologies. You are starting from a blank project. You're starting to create that most awesome thing you wanna do. But if you go somewhere and you tell people that they have to work on a project that is like 4, 5, 6 years old, everyone gets a very gloomy face, like, oh, legacy apps, I had to work that. Please, let's not spend a lot of time doing that. And so this lecture is about what qualities and what nice things that you feel when you start a new project get lost over a span of 6 months, a year, maybe a couple of years. Why do people get that gloomy face of dread when they have to work on a legacy project? And most importantly, what can you do about your own projects that will allow them to keep that fresh feeling? And when someone starts to work on that project, they'll be like, oh, that's a pretty good project. Doesn't matter that it's 3 years old, I actually want to work on it and it's interesting. So it's not a very clear distinction what we mean by a new project versus an old project, but we're gonna go over some of the things that help us differentiate between the two. And there are some things that are quite obvious that happen when you start a new project, and when you start working on something, you feel that it's new, versus there are other qualities that kind of come by default. They happen in the background, and not many of us think about those things, but they're also important for the long-term maintenance of that project. And as I said, we're gonna talk about what of those things that are in the beginning, but they're usually not as there as the project progresses. So in the beginning, you do most of your research, meaning you find the most current technologies, you find out what's hot in the field. It may not be hot after 2 years, especially for web apps. So this lecture is not going to be very specific about web apps. It's going to be more about software development in general. But my personal experience is that especially with web apps, there is a bigger problem as this field is developing very quickly. And so we experience project rot a lot more. When you start the project, you also choose all your dependencies. And I'm going to have a fair bit of slides about dependencies, as I think they're one of the more important aspects of new versus old projects. Also, you establish the project structure when you create a new project. When you start a new project, it might be small. It might not even be small. It might have a lot of features, but eventually, as you continue to develop the project, almost in all of the cases, it outgrows itself when it was in the beginning. And so this project structure might not be as relevant in the future as it is right now. And also, you create processes in the beginning. Some processes are formal. If you work for a large company, it might have a lot of processes around how you write code, how you commit code, how you test the code, how you do stand-ups if you do Scrum, and things like that. if you work for a small company, a lot of the processes are informal. The way you communicate with your colleagues in the beginning is gonna reflect a lot how you communicate with your colleagues when you become 2 or 3x the size. And so some things that you're not very conscious about in the beginning can have a lot of influence how you do things as you move forward. And given the topic of the presentation, probably everyone understands that the way we communicate and the processes we create in the beginning might not be very, very good for 2 years going forward. But if you want to make a project that's going to be a pleasure to work with in 2 years, you have to think about a lot of these things. However, everything that I'm going to say, probably I'm going to say some things like, you should do this or you shouldn't do that. Everyone should realize that all of this is a trade-off. As they say, there is no free lunch, meaning there is probably not going to be a thing that you do in addition to the standard things you do that is not going to cost you something. Once we escape all of the very bad practices of software engineering, once we go to like kind of a middle level of quality of everything, all the decisions you make, all the choices, they're going to have some positives and some negatives, and there is rarely something, oh, I should definitely do that. All of the things come as a trade-off. You win something, you lose something, and in order to decide what to do, you need to realize what those trade-offs are. Otherwise, you cannot make a good decision. For example, a lot of the things we're going to talk about is how to plan for the future. How do we start our project and how do we behave, so to say, in the next 2 years so that we keep that fresh project feeling. But imagine you're working for a startup and you have to deploy an MVP in 3 months. If you start thinking about what I'm going to do with this code base in 2 years, you're inevitably going to be distracted from that MVP. And so you have to be very aware what those trade-offs are. If you plan for 2 years ahead, your short-term goals may be impacted. By knowing the trade-offs, you can minimize this impact, but you have to be very aware it is there. For example, planning for updates, software updates, they definitely do take time and energy. If you plan for how you're gonna update your dependencies, how you're gonna update your OS, for example, everything, that's gonna take you time and energy now that you might not be able to spend on writing that crucial MVP. Following best practices. We always hear best practices are good. Sometimes they aren't. Sometimes you can achieve something in 10 minutes that if you need to follow the best practices, you will need 30 minutes to do. And that compounds over time. If you spend, so to speak, a 3x multiplier somewhere and then a 5x multiplier somewhere else in order to follow those best practices, you consume those resources needed to deploy something as quickly as possible. If your company, for example, doesn't exist in a year because it failed to deliver, those best practices are going to do no good for you. However, for some projects, this is very important. You know that what you write will be deployed in 6 months. You've planned well, and then you need to plan for the long haul. This is very lacking. For example, as a culture in the Silicon Valley, in the Bay Area, a lot of people are looking to write something in a couple of months, get some customers, and then exit. In a lot of cases, we need to plan for the long haul, and that's why we're talking now. Maintaining your code structure. It takes time, it takes energy. Like I said, it can distract you. In this talk, we're not going to go over something that's terribly creative. I'm not going to teach you how to, for example, write good software, but it will probably help you. Hopefully, it will help you understand what the trade-offs are and help you shape your thinking. If you think about long-term maintenance, what do I need to keep in mind in order to be able to achieve that? And as we said, you need to be very conscious what you're getting and what you're losing when you implement those practices or when you even spend your energy thinking about the things that we're talking today. We're gonna be talking about very few hard rules, meaning very few you should do this in that specific way, but rather you should use your judgment and use your experience to decide which practices to adopt and which you shouldn't. And we're gonna talk about what they give you and what they take from you. Like I said, we're gonna talk a lot about external dependencies, and hopefully they aren't, but in a lot of cases they are the source of a lot of trash that can be very easily dumped straight into your project. We're gonna talk about that later as well, but your dependencies, you can treat them in a lot of cases just like a part of your code, meaning if you change them, you change your code as well. If they break, your product breaks. Like there is no distinction between mine and theirs. Your customers, they're not gonna care about whether your site crashed because of your dependency or because of your code. It's gonna be your product that's gonna take the hit. External dependencies, I mean, think databases and libraries, basically everything you pull into your project that provides some kind of functionality or even like non-functional things, at least non-functional as far as the customer is concerned, maybe internal tools, everything like that. And yes, they're a potential source of a lot of headaches or a lot of pleasant feelings if you choose them right. It pays off in the long term, choosing your dependencies. A lot of people choose them by just judging, are they gonna do the job I wanna do right now, or it doesn't do the job I wanna do right now. There are a lot of additional qualities that you can look at that will help you in the long term that are maybe not as obvious if you think just about the current moment. I've seen a lot of people, maybe not you because you're very smart, but a lot of other people that are not here, they choose libraries in like 1 or 2 minutes. They just Google something, they open the first link, they're like, okay, this seems like it's gonna do what I need it to do, and they go and proceed to use it, and then they hit a lot of roadblocks. And my personal experience is that if you spend less than 10 minutes on choosing any library, then there is the potential of having headaches down the road. Google has a very good ranking algorithm. That doesn't mean that the first result is always the best for you. Maybe some of you remember what happened with LeftPad on NPM, I think a year or a couple of years ago. It's probably not something that you could have guessed before it happened, but there are a lot of things you can guess, or at least you can reason about, and that's what we're going to talk about. And so we're talking about carefully choosing what libraries you use, what dependency you use, but what qualities do we actually look for, and how do we actually choose that good library? Everyone knows they have to choose right, but how do we actually do that? There are also things to consider for larger dependencies, like the database that you use, the cache server that you use. Maybe you're choosing between memcached versus Redis. These are somewhat overlapping with the way you choose libraries, but there are also some crucial differences. We're going to be talking a bit more about the libraries, but we're going to mention the larger dependencies as well. So how do you look for a good library? There's you can see over there, the main GitHub page for the requests library for Python. It's probably one of the most used libraries. A lot of you even take it as a default one. Now, you don't have to write Python to understand what I'm going to talk about. But let's look on the top. There's 1,100 people that watch these libraries. That's a lot of people. 27,000 stars and 5,000 forks. Now, we don't have to spend the time to go over what each of these numbers mean, but you have to look at all those numbers, how many commits it has. Maybe you want to dig a little bit deeper. Look at when was each directory last modified. Maybe you care a lot about the documentation of a certain library. You can look that the documentation of this library was changed 10 days ago. For some libraries, it might be 2 years ago. Maybe you will see that the code changed 1 month ago and the documentation changed 6 months ago. That means probably that the documentation isn't updated as frequently as the code. That may be a good thing for you if you consider yourself a hacker and you can open the source code of the library and you prefer that in place of the documentation. Maybe that's a very good thing. Like the people care a lot about their source code. Maybe you just don't want to spend that time to dig deep and you just want to have an easy way to do it. Just look at the documentation, copy a few examples. Even if you're a very good developer, that's often the case. You cannot spend your time freely everywhere and just hack with every library. Sometimes you need the job done right now. So, and this is just the homepage of the library. There are a lot of other signals you can get. Let's go over some of the important factors. You need to judge how big the community is, and not only how big it is, but also the quality of the community. So everyone has heard probably good things and also very bad things about the PHP. I would say it's an example of one of those communities that have a very large size, but the people who really know what they're doing is probably a smaller percentage. If you go to something that's more niche, like maybe Clojure, maybe some data science tool like R, maybe it'll have many orders of magnitude smaller community, but the community will be more active, it will be more engaged, it will be easier for you to get help. So there are a lot of ways you can judge that. You can look at the mailing lists, you can look at Stack Overflow, and then there's the documentation. All of us talk about the documentation, but it's very important to go through at least most of the documentation, even before you start using a library, to determine, is it well structured? Is it complete? Does it tell me how to do what I want in an easy way? Or do I have to dig through the reference in order to decide how I can achieve what I want to achieve? There's personalized support. It can be free, meaning mailing lists, Stack Overflow, just volunteer effort, maybe by the library's author, maybe by someone else. And also there's potentially paid support. For some libraries, you can get both. For some, you can get only one. Maybe in some contexts, you want paid support because you're a large corporation, you can afford it, and it will save you more time than you're going to waste money. Maybe you don't care about paid support, but you have to think about that beforehand. You need to look at how frequently the library releases versions. For some pieces of software, it's very important to release versions frequently. For example, if there's a lot of potential for security breaches, that's not always a bad thing. Sometimes the nature of that piece of software that you're trying to use just is a huge entry point for your application, so people are always attacking it. And it's important to patch those things frequently. Other things, you want to be very stable. You don't want to mess with API changes a lot. Maybe you want something stable that has evolved and is now rarely gets releases just because you want it to be a foundation and not adapt to changes constantly. Security is a very important feature. Every day we're hearing about more and more security breaches of very, very confidential data. A couple of weeks ago, Equifax happened. Hundreds of millions of Americans got their personal information leaked. And so security is more important about the things we do than ever. And so, like we said, dependencies are part of your app. So if there's a security breach in a dependency that you're using, you're installing a security breach in your product. If they breach that, they breach your product, and you can lose customers, you can get a lawsuit, a lot of bad things can happen. And so one of the easy ways you can solve that issue is by keeping them up to date and using dependencies that get good security support and are generally in good standing with the InfoSec community. Especially for open source libraries, you can directly observe the quality of the code. Maybe it's important for you to be able to write inside that library. Maybe there's no library in the world that solves 100% of the problem you have, but maybe they solve 80%, and so you have to write that next 20%. And so you need to open the code. Even directly in GitHub, you can just open the code even without cloning the repo. You can see well, is it going to be easy for me to write there or not? It might be very high quality code, but it might not be in a language you understand or can write in. Maybe it's not that popular in your organization, or maybe it's kind of subpar, but it's written in the main language that you write in, and so it'll be easy for you to make any changes that you need. And maybe that's a lot of bonus points for the library you decide to choose it. This is definitely not an exhaustive list. There is probably at least as many of these points in addition. And so you need to apply your judgment what's important for your project and for you, not only in an abstract way, is that library good. And now that we're talking about libraries, an important topic is updates. I presume a lot of people are looking at a working system that is maybe 1 year out of date or 2 years out of date. No updates have been installed, and you think, oh well, why should we change something that's working? If it's working now, let's leave it like that. And that will create a lot of issues down the road. In my experience, I've observed 3 types of projects in terms of the way they handle dependency updates. A lot of projects just never update. They start with some versions and they stick with them. Well, probably if the sky is falling, they're gonna install a new versions of something, but unless that happens, they're just gonna stick with whatever they have. Some projects are in the middle of the road. If they really need to update for some reason, maybe a critical security patch, they're gonna do it, but otherwise they don't bother. And we're gonna talk a lot about the projects that always do security updates and also always do version updates. They always keep everything up to date. We're going to talk about why that's good. We're also going to talk about why that's bad. Like we said in the previous slides, nothing comes for free. Always is good for a couple of reasons. Sorry about that. So when you do security updates always, that means that if someone fixes a small bug, if someone releases a security update that hasn't been yet widely publicized, but someone found it and fixed it, you're always getting a lot of these goodies. Maybe there's something small that's nagging you, but it's probably not worth the time to update. If you have a policy of always updating everything, you're gonna get all of these kind of by default. You're just doing it because you know it's good and you're gonna get them, and all of these improvements stream in. Of course, there can also be bugs that come in with the new versions. There might also be new security breaches, but if you chose your dependencies well, they're gonna be tested well and audited well, and that means you decrease the chance of something bad happening with the updates, and you increase the chance of something good coming with that update. There's a lot of fear, uncertainty, and doubt coming with updates. Some of that we already talked about. But there's also this case where if you haven't updated the project yourself until now, maybe one of your colleagues does that updates. Maybe they left, maybe they moved to another project. If you personally haven't done updates, and if that's not the policy of your company, you're probably not gonna know how to do that easily. And more importantly, you're not gonna know how do I check if the project still works after I do the update. However, if your project and your company, they have a policy of always keeping things up to date, then there's gonna be either a lot of automation created around it, or there's gonna be a lot of documentation. And so you just go in there, you follow the steps, and you've done the update. The next time the update comes, you're gonna be confident that you're gonna know how to do it, you're gonna know that the project works after that, and so you're now part of the good people that always do updates. There's a lot of, well, not a lot of, some amount of tooling available around updates of dependencies. If you're talking, for example, the OS, all of the modern operating systems have a very easy way to update. If you're a developer, if you're writing in Python, if you're writing in JavaScript, which is what we in HyperScience basically do for our product, there are some easy ways, for example, to see your outdated dependencies in terms of libraries with these two popular package managers for those ecosystems. Of course, this is not meant to teach you how to update your dependencies. That's easily done using the documentation and plenty of online tutorials. But at least you need to be aware that there is something that can tell you, oh, there are these things you need to, or that have updates available, and you go over them and follow your standard procedure. There's also some software as a service available around that. Sneak.io and PyUp, they will automatically scan your project in some cases directly from your GitHub repo. They will find what your dependencies are. They also have databases, for example, of important security breaches. And so if they detect that you're using a version that has a security breach, or there's like an important reason why you should update, they give you a notification and you have time to react. We're going to talk a little bit about testing. Why testing is important? Probably a lot of you know at least 3 reasons why testing is good and how testing can help you in the present moment write better code, more reliable software. But testing is also very important in the long run. Reliable testing pipeline is very important if you want to keep your software fresh. A lot of the practices and the way we do things in the software development industries change, and they change constantly. And in order to keep that fresh feeling, we need to change our software as well. Otherwise, it will grow stale. And one of the most effective things that will allow you to make those changes in your software easily, painlessly, and quickly, probably the most important one is reliably, meaning you're not going to break the software by updating. You're going to get shouted a lot by your project manager, maybe some of your customers, if it's an important piece of software. You definitely don't want to do that. If your project manager asks you why is the release broken, and you tell him we were doing scheduled updates, there is some chance he will tell you you should stop doing scheduled updates because you didn't have to do them and they broke the software and we're not going to do them. Whether that makes them a good project manager or not is a completely separate topic, but there's a chance that they will tell you that. If your updates always work, they're going to be very happy about that because they're going to get only positives about that. And so a reliable way to test your software is a good pipeline. The standard ways that we test software in, like unit tests, functional tests, integration tests, and so on, they're all very well known. There's probably, you've seen talks or presentations about how to do them and how to do them well. So we're just gonna say that they help keep your code integrity. And also the tools. The tools are very well known. Continuous integration, continuous delivery. Maybe some companies have also manual testers, others don't. But there's also this other kind of testing. It's arguably testing, but I'll just lump it in there. Code style testing. We're gonna talk in one of the next slides why that is also very important. But along with code style testing, there goes deeper code inspection. So maybe, for example, in Python, you can, and in most languages, you can declare variables that share the name with a built-in. And so you can no longer use that built-in in the scope of your variable. This is just one example. There are, depending on your ecosystem, there can be many, many different types of deeper code inspections. If you're using a compiled language like C++, there are a couple of well-known tools that will scan your code for various type of subtle issues that people over many years have tripped over. They discovered and then they made a check for. And yes, depending on your ecosystem, there are lots of tools available like that, and also maybe things that are not as obvious. For example, a good thing to have is something that cross-checks your code against your documentation. For example, if you're writing an API, you will definitely want every single API call to have a documentation entry bound to it, and having at least some amount of text or examples attached to it. And you can write a checker that will check if that's the case, and if not, for example, your build will fail. When you start writing the project, you define 15 API calls, let's say, and then people start adding different things over time. If you look at the project in the beginning, everything is nicely written in the code and also very nicely documented. If you stumble on a bad project and you go there 2 years in development, some things will be missing, some things will be outdated, other things will be completely wrong, and that feeling of code rot will creep in and you'll realize you're working on something outdated. And our goal here is to make projects not feel outdated, and not only feel, but they should behave in a way that's not outdated. You can also check for unused files in your repository. For example, someone wrote some piece of code that was used, but then the thing that used it got removed, the code itself didn't. If you go into a repo and you find that a third of the files are no longer used, you can get a sense of what's used right now, what's not. If you touch something, is the software going to change because it's used or not? And this is, again, one more example. There are a lot of things that will make you feel like you're working on a legacy project, and some of them might also leak to the client or the consumer. Others might not, but if your development experience degrades, inevitably down the road, the customer's experience will also degrade because they're very intricately tied together. Very important point here, experiment with breaking your own process, with breaking your own app, with generally breaking things. Why is that important? If you know that changing a file, for example, adding an API call that doesn't have documentation, breaks the build in a certain way, you will expect, if you see that in the build, then, oh, I'm missing documentation. Maybe you break something, and then you don't see it anywhere. Your build passes, your test passes, your QA team isn't looking for that, and so you've just spotted something that you need to check for. You either add it as a process or you add a build step for it. But generally, this is a way to explore things that you haven't done, and also a way to explore if something breaks, you will know that you've done that before because you've broken it yourself as a test, and you'll know how to fix it very quickly. You either know or you will learn that people are not very good at remembering things, and so automation is the way to go. That's it, break it under your control, not the other way. If it breaks out of your control, you have to get up at night to fix it, and you won't know how to fix it, you'll have to come up with it on the spot. Invest in consistency. Consistency is very good and it's very important. Changing a system that is ordered a certain way to be ordered in another way is very easy. Installing order in a chaotic system is a lot more difficult, and so you're never going to be perfect on your first time, maybe not on your second time, maybe not ever, but if you are consistent in some imperfect way, you come up with a better way, it's very easy to migrate. Maybe even automation will help you. And if you're imperfect the same way every time, that helps you a lot. For example, you have to come up with a variable name. No one comes up with perfect variable names. They're either too long or too short, or they miss the point completely. But imagine you come up with something, and then you forget about it, and then you work for a month, and then you have to remember what that variable name is. Actually, you don't have to remember. If you're consistent, you can come up with the same variable name that you did last time because you think about it in a consistent way. And so you have to remember a lot less things. If you're consistent, then that makes automation a lot easier. Maybe you can spend 5 minutes to write a regular expression that will help you go over your entire code base, potentially thousands of lines if it's an old project, and will adapt what you used to do to what you want to do now. If your project is chaotic, there is not going to be an easy way to automate it, and you'll have to spend many hours going over those things manually. Create a style guide for everything. Your style guide doesn't have to be perfect, like we said, but if you have a style guide for everything, everyone on your team is going to be on the same page. If they're on the same page, they're going to create consistent things. You're going to get all of those benefits that we already talked about. Enforce as much of your style guide as possible, meaning use linting tools, use static code analysis tools, use as many build steps as you can in order to automatically enforce as much of that style guide as possible. That will just reduce the amount of time you spend with your colleagues during, for example, your code review. You go over how the code is formatted. Ideally, that shouldn't happen at all, just because maybe Git won't even allow him to commit if it doesn't follow the common style guide. And if someone decides the style guide is imperfect, you change the style guide, you change your, for example, linting rules, and then in one click you have a list of all those places where that new style guide is not followed. Some of the most modern linting tools also have ways to automatically fix the errors it discovers, especially if it's simple code formatting. So you just change, if you're using ESLint for JavaScript, some of the rules have auto-fixers. You change the ESLint RC file. You no longer want spaces, you want tabs, vice versa, it doesn't matter. You change it, you write --fix on the ESLint command line, and it goes over your entire code base and fixes it. And that's why it's very nice. That's what we were talking about. Change the things you're enforcing, and it's very easy to fix your entire system to follow that new guide. Some specific tools that will help you with web apps. There are a ton of very well-known tools. We'll talk about some of the maybe a bit lesser known tools. Some of them you will know, others you may not. First, there's ESLint, which is what I use, but definitely one of the couple very good options. There are others. It's a JavaScript linter, meaning it can enforce a huge amount of rules on your code base, providing you with what we just went over with. Flake 8 is what I think the best linter for Python, not because it's very feature complete, but because it's very extendable. There are a lot of plugins available for it, and it's also very easy to write your own plugin. And I'm a huge proponent of writing your own plugins because your organization is probably going to be a lot different than others. There's Coverage.io, which is probably the best tool for Python for checking code coverage. And checking code coverage is important because it helps you remove stale things or identify things you haven't tested. Sauce Labs is interesting. They also have a competitor. I haven't listed it here. And this is not a recommendation. This is just to go and look at the type of thing, and then you can choose your own. Sauce Labs will give you the ability to run Selenium tests or to just manually go to a machine and interact with it. That's running iOS, that's running Android, Windows, Linux, all of the major desktop, mobile, tablet operating systems, and also all of the browsers. If you're not using Windows day-to-day, you don't have to install Windows just to test under IE. This will allow you to do that, and it will also allow you to do it in an automated way. There's Percy.io, which does so-called visual regression testing, meaning, and this is something I grew very interested in recently, if you change, for example, a CSS rule, it might not be obvious what are all the places where it is used. Percy will take a screenshot of all of the pages on your web app. It might be internal, it just uses your Selenium test. It will tell you what changed with a given code change. And if you change something inadvertently, it's very easy to see and and adjust. Git hooks are very important. They allow you to execute actions when certain Git commands happen. If you don't use Git, I'm sure there is the equivalent for your source control system of choice. But it's very important to be able to automate at least some basic checks when you do actions with source control. Pony checkup is interesting. It works for websites written in Django, and I'm sure there are similar tools for other technologies. It checks for frequent errors that you can do in your Django configuration or settings that open you up for mainly security breaches, but also in some cases like missing functionality or something that will break under certain conditions. And it's very important to check what's available for your ecosystem. These automated checks, they might take 10, 20, 30 minutes to set up, and then maybe they work for many years in the future. If they save you 1 or 2 emergencies, then it's definitely worth it. And so let's take a minute to do a quick rehash of what we just went over it. What are the most important things? And so first, code rots. If you write something, it doesn't change. It doesn't get rust like maybe the car you have. It doesn't gather dust, but still it deteriorates over time. Not because it changes, but because the world around it changes. There are no silver bullets. You're not going to do one thing that solves all of your problems, and the things that you do don't come free. You have to use your judgment and your experience to decide what you should adopt and what you shouldn't. In some cases, you should follow all the bad practices just because you need something quickly out the door and you're not going to support it. In other cases, you're writing something that will last for years. People forget is the next very important point. I am a very forgetful person. If I make a mistake, I try to automate a check that will prevent me from making that mistake in the future, or at least I will document that mistake and how to avoid it so that everyone else who's at least following the documentation can avoid making that mistake. The next point, the thing we spend the most time on, choosing your dependencies. This is very important. It's a lot of other people's code coming into your product. You can get a lot of security issues from that. You can also get bugs from that. You should choose it just as carefully as you write your own code. Don't dump garbage into your project because it's very easy, and then you're going to have a bad time. Now, as for updates, remember to remove as much as fear, uncertainty, and doubt as you can from the process of making updates. If you do that from the beginning, yes, you're going to spend effort and time, but the longer you delay it, the more painful it's going to be, the more likely it will be you won't do it. And if you don't do it, you will fall into bad places. Don't try to be perfect. Like we just said, just be perfectly consistent. If you're perfectly consistent, it'll be easy for you to become better. You're not going to become perfect, but you're going to be better. And use the tools that are made by other people to help you, especially in the long term. The more ready-made things you use, the more you allow yourself to focus on the important things and allow those tools that you use to evolve with time, just as you evolve your project, and everything will keep being just as fresh as when you started, hopefully. Now, my teammates and I from HyperScience, we would love to demo what our product does on our booth. And most importantly, we also have a game challenge that's basically, you can write an AI that plays the very simple game of Snake, and we are showing all the different bots that people submitted play against each other on the screen at our booth, and we invite you to write your own bot, look at it play, and then if it beats the other bots, you will get one of our awesome rewards. For more information, you can go to our website. You can learn more information about us. You can learn what job openings we have, and also get our contacts. And that's about it. Now it's time for me to look like that little guy over there, flooded by questions, or maybe even discussion points. Anyone?
All right, so let's first applaud Ivo.